Welcome to Wild Turkey Science, a podcast made possible by Turkeys for Tomorrow. I'm Dr. Marcus Lashley, Professor of Wildlife Ecology at the University of Florida.
And I'm Dr. Will Gulsby, Professor of Wildlife Ecology and Management at Auburn University. We're both lifelong hunters and devoted scientists who are passionate about hunting, managing, and researching wild turkeys.
In this podcast, we'll explore turkey research, speak to the experts in the field, and address the difficult questions related to wild turkey ecology and management.
Our goal
is to serve as your connection to wild turkey science.
So we're here today with Colter Chitwood. Colter, appreciate you joining us. Colter is an assistant professor in the Department of Natural Resource Ecology and Management at Oklahoma State University. Colter, we're glad to have you on, and I noticed that he has exactly 2 more turkey fans in his background, Marcus, than either of us.
Yeah.
Well, I've got the padded room, remember?
Yeah.
So
that's right.
yeah,
He's still leaning on that.
You should see the pile
has
off camera, though.
Oh, yeah.
So the rest are off camera.
Could you move the camera? I'm just kidding.
Yeah.
Don't do that. But is it intimidating you, Will? That's what I need to know. This is actually what the fans look like.
Mm-hmm.
Retrices.
Yeah. And those are Montana. Those are, well, one might be Washington, but they're Western fans. Yeah.
Yeah. I'm a little bit disappointed you don't have any Fort Bragg fans on display.
Well, the ones off camera, one of them's Fort Bragg.
Yeah. Well,
so that's a wrap on that episode. We just wanted to show y'all what a fan looked like today.
Yeah.
Yeah.
That was easy.
Yeah, I know that Will knows, but the audience may not know that Colter and I we're in the same lab during our PhD program and worked together at Fort Bragg on, the same work, lived in the same field house together, and did a lot of the work together, including some turkey stuff. Mm-hmm. So, old friends and colleagues, and we have sat on a tree and brought some turkey home on the same day, even from Fort Bragg. I think we were in different groups in the days that
That's right.
we co-killed, but fun times.
Mm-hmm. Indeed.
So,
but I'm glad to be here. Appreciate it.
If you have, we were glad to have you, Colter. Will, if you it sounded like you had something on your cusp. So,
yeah, I mean, I guess we can jump right in. Colter, one of the main things that we want to talk about with you today is this analysis that you've been working on. Kind of going back and trying to, I guess, amalgamate a bunch of data. Folks have been working on turkeys for a long time. And one of the things we're not always the best at as scientists is trying to bring all that data together and look at the bigger picture of what it says. Mm-hmm. So can you tell us a little bit about what y'all been doing towards that end?
Yep. That's a perfect way to summarize it, because that's basically what happened. And we may talk about this a little bit. We've started a project, a turkey research project here in Oklahoma, funded by the state agency. And in the process of writing that proposal, I was actually turkey hunting with Dwayne Elmore, who I believe y'all have had on here recently, in Southeast Oklahoma. And I had been, looking at the papers. I was familiar, I come from the deer world more so, right? I've worked a lot on deer and elk and that kind of thing. And you see these kind of synthetic reviews, and it just dawned on me at one point that with all this kind of increasing concern, particularly across the southeastern U.S., about apparent declines in turkey abundance, there wasn't really anything synthetic. There's a lot of valuable data, but there wasn't something that brought all that together into kind of a single framework. And so I more or less hatched that idea, daydreaming while on a turkey hunt, and then I started talking to Dwayne about it. And at the time, again, our Oklahoma project wasn't even funded, but we started down the path of essentially doing a review paper led by a postdoc here named Dave Londy, where we could basically, and I don't want to bore your listeners, right? But academically, a review paper, you're gonna put a bunch of search terms together, search all the terms, find all the papers. Some of those are going to apply to the data you want to use, and some don't. And so you have a list ahead of time of how you include or exclude studies. And so number one, we're able to summarize what all those studies were about, and that in and of itself has value. But number two, we're actually looking for what we call vital rates out of those studies. And so vital rate kind of loosely are these quantifiable metrics that are most important to explaining population performance, right? And you could do that for white-tailed deer, you could do that for elk, you could do that for bighorn sheep, you can do that for wild turkey. And so our search was around finding papers that reported vital rates in whatever context that they were deriving them, and then seeing if we could bring them together in kind of a unified framework to evaluate these vital rates over large scale and time, right? Because as y'all mentioned, we got people have been doing turkey papers for 50, 60, 70 years, depending on how far back you go and how good the publication record is. But how do you bring some of that data from that long ago where methods were so different, and even reporting styles in the papers were so different? Bring that up to now, where if a paper came out tomorrow, the three of us, we kind of standardly expect how they're going to report their sample size and the estimate of variance and all that. So again, I don't want to bore the readers, but that's the long version, is basically a daydream during a turkey hunt, an apparent need as far as we were concerned in the turkey literature, and an effort to hopefully use all that so that we could think and talk about where we need to put research or management resources going forward.
Yeah, I'm glad I'm glad this happened to you on the side of a tree. I think that's one thing that we kind of touched on a little bit with Will and I have, and probably on some episodes, but we definitely all talk about this a lot, that growing up hunting and fishing has really inspired a lot of, where we're at in our in our profession, but also the kinds of questions that you ask and the perspective that you have on it. And there's a lot of value from having that background knowledge about a species. I mean, people that hunt turkeys intensively to know things about turkeys, and that you might not get if you weren't sitting on the side of the tree chasing them. Doing that sort of stuff, interacting with the species so much. So I'm glad of that. But the other thing,
and it makes it less boring when you're trying to wade through. I mean, that's a lot of work, to look through so many papers, but when you're excited about thinking that has value, it makes it a lot easier.
It means something to you.
Yeah, it has a personal meaning to you, but you also, because of that personal connection, you have some real clarity in what kinds of questions are needed. The other thing is, it's super valuable to go through this kind of process because, like you said, you've collated all this information, and that gives you this nice look at it. But the other thing, I think it came up when we were talking to about predation and the predator experiments, and one of those we had Dwayne on. You start to see holes. And before you put everything together like that, it's more difficult to observe that there are holes in it. And I think the predation, with trapping experiments, was a kind of a glaring hole that, at least for me, that it sort of took me a little bit off guard, because it's such a popular topic. I just assumed we would have more than 2 papers on it anyway.
Agreed.
And you've done this also with a whole suite of vital rates that are pretty important for populations, and I think that's one real value that we can gain from it, is there's probably some holes that need to be filled.
Yeah, I agree. The predator piece you mentioned was surprising to us as well, and like you said, I think you and Dwayne, y'all have already talked about that, so we won't maybe don't chase that rabbit today. But one of the other ones that when I say vital rate, and now if we kind of clarify that definition that much more, we're usually talking about survival and reproduction. Right. And it can be complicated to figure out how to calculate some of those things. And your listeners don't need to know the ins and outs maybe of some of the math equations. But our review did show us that we have very little actual survival estimates at the poult stage.
Mm-hmm.
So assuming that a nest hatches, what happens there?
So can
And
you just real quick,
mhm.
so that the listeners and us, do we know what were the primary metrics that you're looking at with vital rates? You
Well,
said
so
nest survival and poult survival. What else is there?
yeah, so poult survival. Then there's a period of time where most people cut off when they're done being a poult. I think we used 28 days because that's pretty commonly used in the literature. You could arbitrarily define that different. Well, then there's a period of time from day 29 all the way around to the next spring when, let's pretend that's a baby hen, right? And now she's grown up and now would have the opportunity to nest for the first time. We called that the youth stage. We adopted a term from outside the turkey world, but in the bird world, where it's kind of like a big missing piece, and we of course know that's difficult to get because we can't make tiny transmitters that go on a 2-day-old poult that are going to last a year. Not yet, but maybe that, maybe some of that data comes later when the technology gets better and better. But your survival is basically, you're thinking about like through your life, right? It's from being the tiny infant to the kid, to the young adult, to the full-on adult. Well, we're doing that with turkeys, poult, youth. Okay. Then they're in their first year of life. Then they become a second-year adult, and after that, like we obviously can't age turkeys quite the way we do with some long-lived animals like deer and elk. It's much more difficult, but we can at least put them in that stage, right? That they're a full adult hen. So we're looking at survival across all of those periods. And then at any point, once they can reproduce, we're looking at the reproduction components. And that's everything from nest initiation rates to clutch sizes to hatching rates, because sometimes you could have a full clutch laying there on the ground, but if only half of them hatch, right? That we need to know that, and maybe that's an area where we're not sure why that would be happening. Now I'm making up scenarios here. I'm not saying that bunch of studies reported low hatching rates, but I'm saying all of those little tiny details go into kind of the main vital rate of reproductive success, which we usually know in the form of nest success.
Right.
So, yeah.
Now, what was your rationale for separating hens out? Or I guess you did it for both sexes.
No, we did female only for this.
Okay. So for females, what was your rationale behind separating them out into 2 years old and 3 years old or older? Biologically, because I've maybe naively always considered, females once they reach about 2 years old, that things stayed pretty consistent from a reproductive perspective.
Well, and this is where the terminology gets difficult. So I might correct kind of the way you said it. And if we think about it, instead of age for just a minute, think about it as a hen who's got her first nest on the ground. That's around her first birth. It's kind of weird with turkeys. It's around when she turns 1, but she might actually lay the eggs prior to when she hatched the year before.
Yeah.
You know what I'm saying?
Right.
Like if she hatched on May 1, but she lays her first nest the next April.
Yeah.
In the deer world, it's really easy for us to think about that birthday happens and then other things happen. And so again, I don't want to get in the weeds. Like that actually makes the modeling kind of difficult and technical. But that's why we broke it out, because there is evidence that inexperienced hens, i.e. the hen at her first nest, might be different in things like hatching success, or nest success, clutch size, etc., than one that has now come around and laid her second nest, i.e. around her second birthday.
Okay. So
after that, we do treat them all the same, like you said.
So the ones that you were calling second year birds were actually still jennies. It was their first nest.
Correct. They're turning into second year birds.
So they would have, for example, been born in 2021 and they were in their second year, 2022, and that spring they're laying their first nest.
Correct.
Gotcha.
Exactly.
Okay. Thanks for clearing that up.
And then you rinse and repeat to the next year.
Yeah.
And once you get there, we can't really sort them out.
Okay.
And you're right. After that, we pool them. But we've broadly agreed in the turkey world that after that, a second and a third and a fourth nest, if a hen lives that long, starts to be more consistent than what we might expect early on. And that is analogous to what we do in the deer world. We don't expect yearling does necessarily to reproduce at quite the same
Right.
success rate that a full adult does.
Sure.
And elk, it's even more important. So, so yeah, does that answer your question?
Yeah, it does. Yeah, it does. We're on the same page.
So when you're going through this process, Coulter, that you've collected all these vital rates, and I'm sure that not all of them are reported in every paper, so you probably are kind of piecemealing these things together. And what are you? I could see where you're just pulling it all together and maybe just kind of getting an average of those different things, but you were doing something a little more advanced than that, I guess, with your approaches. I'm really thinking of it more like a meta-analysis where you're analyzing papers as your observations. Can you elaborate kind of, without writing out the model? We don't want to.
Yeah. I'm not going to whiteboard it out, and we're not going to put everybody to sleep, but actually that the way you described it, I think is a great way for a hunter, or layperson who's just trying to understand how deeply we have to think about these things, because the modeling framework, as Will just illustrated, it's very definition specific. You got to get very careful with how those vital rates are populated into the model. But what you said, Marcus, is correct. The challenge, the value of this, my argument would be the value of this is for 50 or 60 years, we do have piecemealed estimates all over the range of turkeys. And not everybody studies everything. That's okay. But they are studying it for different numbers of years, with different sample sizes, with slight methodological variation, slightly different analytical techniques. Well, if we just grabbed all that together and kind of took an average, we still need to know some amount of variation around that, right? If Will just said right now, if he blurted out, I think hen survival is 0.7. Okay. But does it range from 0.5 to 0.9, or does it range from 0.65 to 0.75? Right? That range matters a great deal. So the analytical framework we're using is designed to be able to separate what quantitative ecologists would call true process variance, meaning the actual amount of variation around what hen survival really is, versus the fact that across all those studies and all that time and all that space, we also have a measurement error component that is in there. It's noise, if you will.
Yeah.
This analytical framework allows us to separate that noise away and get a final answer that, at least according to the methods that we followed, right, and the review process that we used, would be our best guess of a range-wide estimate of hen survival, nest success, nest initiation. For every one of those vital rates, you do the same thing.
So you would have a mean like 50% plus or minus whatever, and that is truly related to the biology of the species rather than the fact that one study used one type of transmitter and the other one did a different.
Exactly. And if a researcher came behind us and said, I want to model some scenarios. I want to make up some scenarios where we tweak what those vital rates are doing under this habitat management scheme or this predator control environment, right?
Yeah.
Well, the value in our paper is we're giving them the distributions, the estimate and the variation to start from. Because otherwise, Will, you could do this now. You could take your Alabama data and do scenarios on it, but you're constrained by the fact that you're using your measurements and your error within Alabama to run your scenarios. This is a step forward in the sense that, as Marcus alluded to, we've now combined data, compiled it from all over in space and time to come up with a distribution that is, and it's careful in science, right? Let's say closer to truth, as close to truth as we think we can get based on the data we have. Again, I'm not trying to, want your scientific listeners to chastise me for talking about truth in science, but like we're trying to move things forward, and I think that's the value of this approach. Is it gives us better answers to start playing with modeling scenarios.
Yeah, and I hear scientists commonly say this, and I have said it, that science builds on itself. And I don't know that that's necessarily intuitive for people that aren't in the middle of it and seeing it build on itself, but this is kind of a really cool example of that, where we've got 50 years of people doing studies, And then
Mhm.
you're taking that and creating a unique overview and perspective and analysis from it that is also laying the groundwork for someone to come along, like you just said, and build on that by doing another thing like that scenario thing, which you could think of, I guess, or maybe you can correct me if I'm wrong, but I'm thinking of it kind of as what actions we take, what should we expect to happen if we take a given action. So like
Yep.
if we uh, do X, how does it affect the population?
Yep.
Based
Yep.
on all of this data that you've put together and analyzed. Is that
Exactly. Yep. That's exactly. I mean, that's back to the day that we was sitting in the turkey woods. It was just the thought of the value of compiling it all and maybe using it as a springboard for other researchers. It doesn't have to be me, but it gives people somewhere to start from that they wouldn't have if this analysis didn't exist. So
I think a good example of that would be that you guys, you had data representing a lot of variation in time and space, as you mentioned a minute ago, but you didn't really look at spatial trends or temporal trends in these parameters. But that's something that somebody could take this and run with and do later on down the road.
absolutely.
I mean, it seems like y'all's primary objective was to really hone in on, what are the factors driving these populations, and which of those factors are the populations most sensitive to?
Yes, that is exactly right, Will. And again, it's back to the idea that if it doesn't exist at all, step one, we felt like, was pull it all together.
Mm-hmm.
But even on the day that we started brainstorming how that would look, we were already thinking about modeling scenarios. We were thinking about looking at different units of time and wondering, if across the history of turkey research, you could pick up on any trends that were more long-term temporal based trends, right? But at some point, we got to draw the line, right? Because in science, we can't have a paper. I mean, that becomes a book if you try to do it all at one time.
Yeah.
Rather, we took the approach that Marcus alluded to, which is, well, if we can provide this first step, there's others that might immediately go, ooh, what about this? Well, now you have a springboard to work from, from our paper. Even if we're not the ones doing it, we may love the idea, but another research lab may be the lab that's actually conducting the work.
Right.
Well, another important thing, and it always resonates with me. Craig said this to me one time: you don't eat an elephant all at once. You eat it one bite at a time, and
That's right.
this kind of thing that's one bite, and it may take a team of researchers in multiple areas that are taking bites to really get at this, and that's important. I think that we need a bunch of scientists in different places with different perspectives working on these issues, and we're not only able to get more work done and get a better idea of how things are going, but we're also challenging each other because we're not in, we don't have exactly the same perspective, and we're trying to, improve each other's work for the resource.
Right.
Yep. Absolutely. Agree. 100%.
Yeah. I mean, one of the frustrating things about this too is that you already mentioned, and I think we could and we should go into, some of the areas that you identified that data are lacking from on turkeys. So you've already highlighted that as an issue, but when you start trying to break up your sample size in this case, which is prior reports, and you break those down by region, then you break those down by, decade or some other time frame, then your sample size dwindles further and further and further down when you've already got one that is smaller than some people would think to begin with, at least in certain subject areas.
Yeah, that's a good point.
Yep, you're exactly right. And the way we treated that is we bring in, so let's say, Will, let's just use your example, and let's pretend you did turkey work in 1995 and the paper came out in 95, but you had measured nest success in 92, 93, and 94. Our framework brings in those three estimates and the measure of error within each of those springs when you measure nest success as 3 data points. And so in that way, you're right. You could go back and carve it up and look at the 90s only. But you also have to look into the paper to say, well, the paper came out in 2000, but which years were included? Was it a 10-year study published in 2000? Or the older you get in literature, and this is no disrespect to things that were published, right? But we do expect now, I think there's a greater expectation of certain things being reported. We ran into studies that that actually didn't report sample sizes,
Mm-hmm.
or they didn't have a measure of error.
Mm-hmm.
So again, in the methods of how we do our search, there were studies that we had to exclude from the meta-analysis, Marcus, to use your word,
Mm-hmm.
because if we couldn't bring the data point in a way that was defensible within our analytical framework, we had to exclude it, right?
Mm-hmm.
And so one of the things that we actually kind of identified, you mentioned some holes, and we come back to that, was also consistency in reporting.
Mm-hmm.
As these projects, I mean, y'all could have somebody on your podcast just about every other week from different states. There's so much interest right now, with
Mm-hmm.
state agencies funding projects and a lot of researchers at universities working on them. When we're logging some of these vital rates, the fact that we could more consistently report, by age class if we have it,
Mm-hmm.
Mm-hmm.
certainly by year if it's a multi-year study. But again, the further back in the literature record we went, we found people might combine data across
Mm-hmm.
several years. Well, if they also didn't then give us sample sizes, we couldn't take that back out to the Will example where we knew
Mm-hmm.
you had done something in 92, 93, 94. Those were very discrete.
Yeah.
You see what I'm saying?
Right.
Yeah. Well, you can
so-
actually get at that error that you're trying to quantify, like how much of it is actually biology, and you can't really do that anymore.
That's right. Yeah. If you don't have some of that information, that's why we had to exclude it. There were papers where there are analytical techniques that we could use to estimate the error on their behalf if they
Mhm.
provided enough information in their paper for us to do that.
Mm-hmm.
Yeah.
And I will not whiteboard that out right now either, because that's a lot of math.
Well, I was
But
going to say,
but
we're
we
getting
did
mighty
include that.
weedy around here.
Yeah, well, we did it,
already,
but we did include that. We tried to include everything we could because
Yeah.
all that information is valuable. So if
Mhm.
we could calculate their error for them, people maybe
Yeah.
long ago in the 70s, we would include it. But
Mhm.
there were studies that we actually just quantitatively we could not allow it to enter the framework because we couldn't account for error. So
Mhm.
so if you will, if now's a good time, I do have a figure that we could talk about. We've been talking a lot about years and the number of
Yeah,
estimates and things like that. Would you like to see that right now?
Well, I was going to, you could bring that up, and maybe it'll be is it related to what you found, or like related to the data you collected, or what are you bringing up?
Yeah. It's related to what we're talking about now.
Okay.
I was just thinking this might have been what Will was hinting at, because we see, and I'm looking now to
Okay.
green, but
Oh yeah,
but you should have
that's nice.
yeah. So you
Yeah,
should have a
so-
figure that if you want to.
Yeah,
If you
we'll
walk you
make
through
this available in a some format on social media. We'll put the link to it in the show notes so that, that people can go and watch what you're talking about here. But this
Yeah.
is a really good visual.
Yeah. So yeah, there people listening right now may not they may not have it right away, and so he may have to listen to it twice. I don't know. But Will, to your point, this is how we show that across study years, which is on the x-axis down the bottom.
Mm-hmm.
You can see 1970, 80, 90, right, all the way up to 2020. And then there are 6 different metrics in this figure: annual survival. So talking about hens,
Mhm.
clutch size, hatching rate, incubation initiation, nest success, and poult survival.
Mm-hmm.
And what we see jump out right away, each of these is color coded, and each bar is the number of those vital rate estimates that we were just talking about.
Mhm.
Right. So, Will, if you had published a paper in 95 that did nest success in 92, 93, 94, those 3 estimates would be in the bar. I mean, in that case, they came from 3 separate years. As long as we knew that, they're in the bar corresponding with their year. Otherwise, we had to lump them in with publication year. But
Will,
what we
sorry, go ahead.
Mark. Well, I was going to say what we saw was what Will was alluding to. That's why I brought this up. Is right away some things jump out where you see very few poult survival estimates.
Yeah, that's what I was going to ask Will. I was like, Will, I was just curious if the same things stick out to you. What sticks out to you immediately when you look at this?
Lack of poult survival studies, lack of hatching rate studies. The other thing that sticks out to me is, in general, there's a lot more work done during the 90s and early 2000s. And then, kind of not much before or after that, just sporadic.
Isn't that something?
Yeah.
Like, it's really, especially for survival.
Yeah.
Mm-hmm.
That one's really clustered. I guess that's 90s and early 2000s.
Yeah.
But
Yep.
yeah, that was the same thing. Like, I'm just curious, Coulter, do you have any ideas on why, like, hatching rate? I would think that would be, since we've had so much on the nesting,
Mm-hmm.
Mm-hmm.
I would just have expected there to be more on hatching rate.
Yeah, I don't remember right off like a mechanistic explanation in the papers themselves. In other words, where people willingly said that they were leaving it out or weren't. I think maybe
Mm.
it was just the idea that seeing that nest hatch in general is usually what the bird world broadly, outside the turkey world, even if we're talking about
Mm.
warblers and everything else, a nest being successful is usually defined as at least one egg hatches.
Yeah.
And so I suspect, and again, not casting any stones, but I suspect it was one of those things that a few people decided to report because they had it, because they are monitoring a nest. I mean, we walked up to one in Oklahoma last year. It was a renest, and there were 4 eggs in it. 3 had hatched, 1 did not.
Mm-hmm.
So if we don't report that, you don't know that in a paper, right? So I think that's probably what it is. Is it just there wasn't any interest in it, and even if the data were collected, they didn't see they didn't see a reason to include it in a paper that otherwise had a bunch of other good data in it.
Mm-hmm.
Yeah.
Yeah.
Yeah, I would.
But that's my best guess.
I would agree. I think it's just one of those things that a lot of us probably haven't considered as being a very important data point to report on.
Yeah.
But the reason it's on there, just to let the listeners know, the reason that it is on there is because when we go back to the beginning of this, where we started talking about that reproduction equation.
Yeah.
It's because it's a piece within how we figure out the reproductive contribution of a hen. And so you're right. I think for some people, they don't think, well, I mean, they lay the eggs and they hatch, right?
Yeah.
Yeah. But what if half of them don't,
Right. And I think it's relevant to a lot of the conversation. I'm thinking back to the conversation we had with Craig Harper on the Tennessee study. That was when it really started resonating with me how much the hatching rate could vary.
Mm-hmm.
And that could be really important. It's not just about laying eggs and then one of them hatching, but they lay 12 eggs and 3 hatch. That's a lot. Excuse me. That's a lot different than laying 12 eggs and all of them hatching.
Exactly. Yep.
So, yeah, that's really interesting. But I think we've been really getting really close to the weeds on a lot of this, and this is a great tool moving forward for people. But there's also some really good information for us right now that you have gotten, like from this analysis. Like what was the overall result?
Well, let me.
I know a lot of people are concerned about turkey populations, and there's suggestions that there's some declining populations, and that's kind of what you're getting at here, right?
It is
range wide. So
and
what's the result?
Yeah, I'm gonna share one more that you can provide to the listeners later. That I think is exactly the answer you're looking for here. The way this analysis works, honestly, the main output, I mean, there are several, but the main output is something that we call lambda. And I usually call it population trajectory. It's also called asymptotic growth rate, which is what you'll see under the x-axis on this figure. What that means is essentially year to year change in abundance. And the take home message from this analysis, which pulled all those vital rates together, like we've already discussed, and then ran it through 10,000 model runs, 10,000 iterations of estimating trajectory, which is lambda. And on average, lambda was 0.91.
Okay.
Now, what that means to a non-scientist, if we just bear with me real quick, is if it's 1, it means your population is perfectly stable year to year. If it's above 1, it means your population is growing. So, 1.01 is 1% population growth year to year. But if it's below 1, like 0.91, which is what our analysis showed, that's a 9% annual population decline. Now, when you pick one...
So when you did, just to restate that, to make sure that I'm following you. When you got all these these vital rates from all these studies and put them all into this really interesting and complex modeling approach that I don't understand. And then that spits out your number of how much on average across, based on all those studies, how much the population is declining in this case per year, which is about 9% less birds each year.
Correct. Now, that one number, of course, comes with some caveat about, well, what's the variability like? And it's also constrained by, as we've already discussed on this podcast, what data come into it, right?
Yep.
Which often, more data in more places is usually a better thing, right?
Yeah.
Well, the way we can at least deal with the variation today, if folks can look at this figure, I know y'all can see it now, but you'll see that on the x-axis where 1.0 is, everything left of that is shaded, representing the number of model runs that showed any type of decline, whether it was a 1% decline or a 30% decline. All of those are in the shaded area. And so the important take home here is that 81% of all of our model runs were declining in some way, shape, or form. Now, that means there were 19% of them that showed either stable or increasing.
Right. And that's just taking that, what I think you called it process variance, but the actual variability in the biology of the animal is being factored in. So sometimes when that falls right randomly in that iteration process, sometimes it indicates a positive lambda, is what you're saying.
That is correct.
But that's little of the time. You said 81%, right?
Yeah, 81% of the time it was showing decline, which is the way we qualify an analysis like this, in the scientific world, because it's not 100%, and it's not always that every situation, every year, for example, in Alabama, you may not be at 9%
well, I think,
decline, or Florida or Oklahoma,
This is definitely something Will and I have talked about with a bunch of people and between us on the air, is there's a lot of variability and that's leading to some of the uncertainty. And even in a process like this, where you're trying to quantify that, there's still uncertainty, but you can just quantify that uncertainty. And in this case, I would say that's a pretty high degree of confidence that the population truly has been in some sort of decline. And on average, your modeling suggests that was about 9% per year.
That's right. That's right.
Okay.
Yep. That's
so
perfect summary. Yep. You're with me.
Okay. Well, Will, I don't know if you have a follow-up question, but I have one immediately that jumps to mind.
Be my guest.
So, you've got all these variables that you've put in there, nesting success and hen survival and all these different things. They're going in there. I'm assuming that they're probably carrying different weight in terms of what's driving, that decline.
Yep.
So are you able to, during that process, you're kind of able to identify what are the key factors that matter a lot, or maybe the ones that don't matter that much?
Yep. That's perfect segue. It's almost like Marcus actually does know about this modeling framework, and he's just playing dumb. I mean, I know he's from, as he likes to say, lower Alabama, but he's a smart dude. Okay. So when I said a minute ago that the main output was that lambda value, the reason I kind of qualified that is because the other important step is exactly what you're alluding to, Marcus. And that is, again, try not to get in the weeds because I don't want to put your listeners to sleep, but there's a second piece here that's called a sensitivity and elasticity analysis. And basically, in layman's terms, it's what you said. It's how now can we evaluate each of those metrics that we've put into this model and how much it affects that lambda value. And summary of that, if we call way back to the beginning when Will and I were talking about those ages of hens, we basically need hens to survive and we need them to nest. Now, you might go, well, duh. And that's fair. I think it is intuitive. It's actually largely intuitive in the deer world and the elk world that adult female survival tends to be the most important thing affecting that lambda. So managers in this case would try to do everything they could to keep that survival value high when they can, right? But what's also important is the variation that's caused by each of those. And we see a lot greater variation in the nesting part. So that's where I think, and I know enough about what Marcus is interested in, and I've known Will a long time, and I suspect he's right there too. When we start talking about what's driving variation in nest success, man, start listing the things we're interested in, right? Habitat related stuff, right? Land cover change, urbanization, conversion to ag or away from ag, prescribed fire, the predator piece, which may or may not interact with the very things that we just listed. There's a whole lot of things that we could brainstorm, and the turkey world at large has been brainstorming about for decades. This analysis is trying to connect that variability to those things. And I hope, give people a springboard to kind of attack those issues and think like, man, okay, I see now that nest success variation is important. And there's only so much we can do to help adult females survive. We can't stop a great horned owl from taking her off the roost. We can't necessarily stop her from flying out in front of a truck and getting hit by a car. What we can do is not shoot her. Okay. So I will say that I think that's a take home out of this is hens are important enough. And this apparent decline is now quantified at I think a significant enough way that it's basically inexcusable to shoot a hen for any reason right now in any area where you're worried about population trajectory. If we're in Montana in a valley where I've hunted, where you get nuisance complaints about turkeys, that is different and that is fine. And they have a fall hunting season for hens there. The only hen I've ever taken in my life was in that way. But if a hen is legal to take in the state right now, and I'm a hunter, even on that last day of the season, I'm not going to pull the trigger personally. And I would advocate that's one thing we can do ourselves is try to protect hens, because this analysis shows that their survival is key, and their survival, of course, is linked to their ability to put nests on the ground.
Sure.
So does that answer your question?
Yeah, I think so. So based on this process, so I'm trying to make sure that I'm repeating it so that it helps me make sure I'm on board, and also that our listeners are with you. So the adult hen survival, it is really important to the lambda, which is what you're saying. But how important it isn't varying much, like nesting. Is that
correct? Yeah. I probably didn't say that perfectly, but you're right.
Well, you
In
may have. I want to make sure that I'm with you, and that's what I kind of got from what you said.
Yeah, in the population ecology world, you would say like the survival rate tends to be more stable.
Yeah,
i.e., there's less variability, and that might mean that managers have a bit less control to tweak that, right? Like let me give a great example, because a lot of people are familiar with deer. If they turkey hunt, they probably deer hunt. If we just didn't shoot any does, we still can't stop them from getting hit by cars, dying of EHD, dying of old age, getting attacked by coyote, right? So we might drive deer survival up to like 0.9. I'm talking about, say, a doe, 0.9, or maybe even in 0.93. But at some point, that's as high as it's going to go.
Yeah,
right.
It's going to die of something.
Yeah, exactly.
Some of them are going to die of something, even if we don't.
So that those estimates are usually much less variable. Even if it's a 0.8, the estimate itself, the variation around it would be much smaller compared to nest success in a turkey, which swings wildly year to year, because you could have a bad spring weather-wise, and that may be the driver in that spring. But when it dumps your nest success down to 15%, and then the next year you have better weather conditions, and now you're back up to 65. Well, what we're trying to figure out is, how do we keep it closer and narrow that variation so that it stays higher?
You're trying to stabilize it, whereas the other one's relatively stable.
Yeah.
Because they're not all dying every time it's dry outside or whatever.
Exactly.
But that may limit you especially if the hen survival is already pretty high.
Yeah.
It may limit you in how much you can adjust that up. But one thing we can definitely do is not shoot hens.
Yep. And the argument for that, if I just rant for a second, because you might like it when I know you let Craig rant, so I might, and it's not really a rant, but I do think the listeners might want to hear it because, we already constrain hunters in a lot of ways with very complicated regulations. Anybody's ever hunted out west knows it's even worse out there when there's
I know about
crazy
that.
units and everything. Well, we have antler point restrictions. And in some cases, you have to know that to be 4 points on a side, it's got to be an inch long to count as a tine. There are brow tine restrictions on elk sometimes, and sometimes that comes with a length measurement. Like it's got to be not only a brow tine, you got to know where it's located on the antler beam, but it's got to be 5 inches long. And people are shooting elk 400 yards across a canyon. So if we trust hunters to do that, I think we absolutely should expect that they can be trusted to identify a male bird, not just because there's a beard there. And to put a finer point on that in the turkey world, there are places where you can't shoot jakes, right? So we're asking hunters to identify beard length, which we know already is potentially tenuous for actually putting that, at least in some cases, right, putting that turkey in the right age class. When you add all that up, I think we can ask hunters. I certainly am volunteering. I believe you two would, to confidently identify a male bird inside 40 yards before you shoot it. And there's plenty of states, of course, where it's illegal to take a hen anyway. So that's off the table. But in others where it's not, this analysis would suggest, and I would, my personal advocacy here would be, don't shoot a hen. Even if it's legal to shoot a bearded hen, you shouldn't shoot a hen. Not if you're worried about population decline.
Yeah, that's a good point. And I think you hit the nail right on the head. With, I would say it's much more difficult to distinguish between a jake and an adult, gobbler. That's more difficult under most circumstances than sexing the individual.
And you're not, and just to clarify, Coulter, you're not necessarily saying that hunters harvesting hens under legal frameworks is responsible for this decline that you guys were able to document, but it's one thing that we can do to try to start moving that needle in the right direction.
Exactly. And thank you for saying that, because that should not be misconstrued. You're exactly right. We have no evidence. Matter of fact, I don't even know if there's enough data. I mean, you'd have to go into states where that's legal and look at their history and probably focus on their records in their state only, but certainly not. Our framework is not an indictment of anyone who's ever shot a hen, so that they do not need to feel bad about themselves. What our work is pointing out is that if we're worried about decline, it's showing us quantitatively the value of that hen being alive. And if one way we can control that is not to shoot her, well, that's an easy management action we can take. So
and
perfect
to add
summary.
Add to that, maybe it came up when we were talking to Mike Chamberlain. Will, I don't recall now, but I remember somebody talking about the level of fall harvest, and it came up with the hen harvest, and I thought that it was relatively low in most places where it is legal. And I don't recall if that was just in the fall harvest or if it's just overall or what, but it probably is a reasonably small amount of the harvest, and even in places where it is legal.
Agreed. And even in the spring, where I'm familiar with there being the possibility of taking a bearded hen, what anecdotal information I've been told about reporting through apps and check stations and whatnot is it would still be a small number. But what if it was, by small number, it could still be well into the triple digits.
Yeah.
I mean, we could be talking about in an average state that allows that in the spring, it could be 300 birds.
Yeah.
So no, that's not the same as your tens of thousands of gobblers, but it's those hens that you need to nest. And so it's a nickel and dime approach, but it's the one thing we can control.
Another way to look at it that's linked to some of our conversations and also some of the previous ones that we've had on the podcast, there's a lot of variability in the success of the hens themselves. And we don't really know what that is, but it's probably not linked to beard length. So my point is, what if the bearded hen happens to be that really good one that's driving production?
Yeah, you're right. There's
So,
evidence that some
even though
hens
it's
are better. Yeah.
If there's, even if it's a small proportion, if some of those end up being the super hen, we'll just call them for sake of argument for a second. If that happens to be the super hen that's driving reproduction, or really important in reproduction, then that certainly could be a problem.
Yep.
Even at a lower harvest level, just because there's variability across hens and who's recruiting poults and who isn't.
Yeah, for sure. Well, Coulter, I know we're getting a little bit short on time with you, and I know one thing that you're really excited to talk about today, and I was very interested in hearing from you on, is poult survival. And how much data do we have on that? What's the relative quality of it? Things like that.
Yeah, that's right. And back when we shared that figure, it's one of the things that popped out to you, I think, when Marcus asked the question. So there's a couple things that I think are worth discussing, and your listeners might want to hear about. And some of them we wrestle with, of course, as researchers, right? Because animal welfare is at the core of what we do. When we're put a backpack on an adult gobbler or adult hen, we are taking a calculated risk that backpack affects that individual survival in some way. Likewise for poults, right? They're tiny. But the technology has gotten better and better, certainly even during our careers, but certainly going back into the 80s and 90s when people were first trying to mark them. And the reason I guess I wanted to highlight that is when we see, number one, a lack of information in that life stage, it means it's missing data potentially, or at least sparse data to try to populate some of these modeling frameworks that we've been talking about. Okay, so you can say, all right, well, that's easy. We go out and get more. Okay, well, a lot of studies, rely on brood counts, flush counts, and likewise, subsequently, a lot of studies came out showing that we know there's biases in how those counts work, because we have to account for a detection process. They're unmarked birds. What if they don't flush this time, but they do flush next time? Are you really seeing a missing, or what I mean is, are you really detecting a missing poult, or did it just not show itself to you that day? And we also don't know at some point, depending on the ages, brood mixing, brood amalgamation can throw that estimate off. So my point is, we're kind of slow pitching the way to, now that technology is to the point that we have very tiny transmitters, I think it's worthwhile to try to get better data in that young life stage. And we're trying in Oklahoma. The quick update on our project from year one with the Easterns in the Southeast was we had such poor nest success, 2 nests hatched, and they were both renests, so they were very small clutches. We only marked 3 poults from each brood for a total of 6 poults. So that's a small sample size, not because of anything we did related to poults, but because we just simply didn't have any nests be successful that year. But the reason I say this is the only way we can really evaluate that animal welfare risk versus our need for that type of vital rate data is to carefully include, that research method and evaluate it. And it's been evaluated pretty extensively in a lot of other upland game birds. And as y'all two know, we've all worked in the kind of ungulate world. It's been evaluated a lot in the ungulate world. Sure, a fawn is bigger than a poult, but you're still putting a transmitter around an animal's neck that may only weigh 4 pounds at birth, right? So I do not want to understate to your listeners that the animal welfare and the lives of those animals comes first. But the reason we're inching forward on these techniques is to try to fill these holes so that we can get better quantifiable information to better manage turkeys.
Yeah, at a population level.
At a population level. And if somebody walked in right now, knocked on my door and told me that here's the hard data, here's the paper, look at how horrible this technique is, and it killed all the poults, I'll stop doing it tomorrow. The problem is that those data don't exist. And most of the data that we have right now, even some of it is not yet published. And I'm not involved in these
Right.
studies, but I'm going to mention that I know there's work going on in Tennessee and Missouri that started doing some pulp marking prior to ours and have much higher sample sizes. And from what I've been told, they have very, very little evidence, like almost literally zero evidence of survival bias caused by the pulp marking. And so when we look back at our figure, Will, to go back to your point, and we sit there and think, man, we've got a lot of good information over time on nest success. What happens after they hatch? Marcus, to your point, how many hatch? Maybe we quantify hatching success better, but maybe we also now really get at this poult survival estimate instead of using counts that we know are biased. If we can demonstrate that the markings on poults are not biased, right, then that's actually a better way to get at survival. And that would theoretically carry through, hopefully as technology gets better, it's possible that carries through even deeper into that individual's first fall and winter. Where right now, and I'm going to use a Dwayne Elmore approach right here, he goes, well, the reason they're all cut off in August, the study's cut off in August because the students got to go back to school. I mean, and he's not wrong in a lot of ways. Yeah. You've got, for most broods, you've gotten past that first 1 month old period, maybe 2 months old. So you think, okay, well, I've got my poult survival estimate. Now it's August. I got to go back, take class. And then we just don't know what happens in a lot of ways between August and all the way around to when we start doing winter capture, you say in January. And so I guess that's probably a long answer to your question, Will, but I hope that touches on everything that there is a trade-off, and we need to be very careful. We need to be very animal welfare focused from a research standpoint. But I think we've demonstrated, particularly in this analysis, that there's a need, and that need might have value in helping us inform how we manage, and conserve.
Yeah, I totally agree. And to provide a little bit more context for listeners too, that might surprise them, is that, it's actually not super clear on whether this reproduction bottleneck that we're currently observing is more so related to nest success or poult survival. That's a little bit up in the air. And one of the reasons for that, and some of the uncertainties surrounding the nest success aspect of the equation, and Coulter, you guys pointed this out in some of this preliminary work that you've been doing that we've been talking and focusing on today, is that these estimates that we have that we're relying on related to nest survival and nest initiation oftentimes don't account for nest losses prior to incubation, or they just go completely unobserved, especially with the older technology in these kind of legacy studies.
Right. Yep. You're exactly right. And then we're back to mentioning technology. I mean, I think the advancements that have happened just in the last 5 years, I mean, we're getting to the point now where not only is it standardly possible to have GPS on those adult hens, but now we're even getting multiple nests out of the same hen, because that battery life will last the next spring. That was unheard of when the three of us were in grad school. So I do think that a combination of us critically looking at where these gaps may exist and thinking about how we might fill them, or why we might want to fill them, to figure out maybe how it might affect managing turkeys. That's paired right alongside with the need for technology to help us drive it forward. Because, I think I joked with Marcus one time that, we didn't used to know where warblers went across the Gulf of Mexico until people figured out how to mark birds in a way that allowed us to figure out, oh man, they're down in South America, and now we're putting little tiny transmitters on things like hummingbirds, that would have been considered completely impossible at some point in the past. And now
not that long ago,
quite standard. So Will, I think you're right. If we can't collect data to tease those two things apart, and my analysis, as you've seen, is going to pick that nest piece over the poult piece, because the poult piece has a scant amount of data.
Well, that's what I was going to, it's exciting that the technology is helping to fill in these gaps, and we're right on the cusp of that with the poult one. It sounds like But that was what you just kind of alluded to, I think, is what my follow-up question to you was going to be is, given that there are some areas, the holes in the literature base that you use for these models, do you think that those are influencing, not necessarily the model accuracy, but I was thinking more about the sensitivity of those. So like the poult survival, could part of the lack of sensitivity be the fact that we just don't have much information on them?
Yeah,
Or
I think
like, how do you view that helping this process?
Yeah, I think that's worth considering. I think the absence of data, like I'm much less worried, for example, about how our model looked at something like nest success, because we can demonstrate that we've got quite a lot of estimates on that, right? But for the ones where the data are more sparse, it for me, it's definitely worth kind of scratching your head a little bit and thinking, well, if we could better capture the true variation across, maybe Will does this in Alabama, and we know people are doing it in Tennessee and Missouri, and we do it in Oklahoma. All of a sudden, there's a lot more data to feed an analysis like this, and I don't. It'd be pure speculation to guess how it would turn out, but yeah, I think that's why we talk back to those scientific building blocks. We can put this out there right now. It may be that in just a few years, somebody else may decide to redo the exact same thing again, just to feed in this new surge of data that's coming from a lot of these new projects. And that's completely fine. It's a stepwise process. And the idea is that we're getting closer and closer to what we think is a better understanding of how to manage turkeys.
Well, and the other thing to add, I know that you need to go do all this awesome work, so we don't want to keep you too long. But one thing to add is, we've been talking about missing holes, but the other thing that was pretty obvious that stuck out to us, I think Will keyed in on it right away when I asked that question on your graph, is the data, even the one that you have a lot of certainty on, is kind of clustered in time. And at that particular time, a lot of the states were experiencing very similar symptoms, I guess, and they were kind of at their peak, I guess, because it was in the 90s, right? So they're at their peak and starting the decline in some places. And then some of the other data was clustered a little bit later where they may have been in the decline. And if we went back to this and then have a surge of data where those populations are in different trajectories, that may give a lot of opportunity to understand, in more detail how these things have changed and may shed some light on what we need to do about it.
Agreed. And that's like we alluded to earlier, we took the holistic approach because we thought there was value in kind of pulling it all together. But you're absolutely right that you could look at it spatially and temporally in different ways and carve that up if you were interested in questions related to kind of what you just described, kind of like 90s estimates versus more that are happening now. Absolutely. I think that's worthwhile.
Yeah. Good stuff. Well, Will, did you have anything else that you wanted to
No, I
ask
think we covered most of it.
Say? Yeah, that was a really great overview of what you guys have been working on, Coulter, and I think we'll want you back if you'll come back to give us some updates on the groundwork that you guys are doing. I know there's a lot of cool stuff that you're working on, and you got more stuff up and coming. So we'd love to have you back to talk about that stuff and let
absolutely
the Oklahoma listeners know what's going on in their state, in near real time. So that'll be really cool. But we really appreciate you coming on to talk about all of this stuff. Is really interesting. It gives us a really great perspective, I think, on what we should be thinking about when we even say something like population decline. Like there's a lot that goes into that, and all these processes that are behind the scenes that are really important. So I appreciate you coming on to tell us about all of it.
Yeah, happy to do it. Love talking to y'all. We can compare turkey fans next time too, if you want to take that carpet down or whatever.
Coulter, is there anywhere that folks that are interested in your work can go to get some updates on that periodically?
We do our natural resources extension here at OSU. I know they're pretty good about updating social media. We run most of our stuff through them, so people can find them on Facebook and Instagram. I think TikTok, all those things. And we do provide periodic updates that way. That's right now. That's the best place. Project's still pretty new, so we don't have a lot of major infrastructure yet. Our Rio Grande piece of the project will start trapping here coming up this winter. So we'll actually have turkeys on both ends of the state.
Awesome.
Marked.
Cool.
Yeah.
I was going to actually respond to, they can go to Wild Turkey Science podcast where we're going to update you regularly on what Chitwood and them are doing. Yeah. Share
That's
it with your friends. If you
Yeah.
know anybody in Oklahoma, send
Absolutely.
it to them.
Okay.
Well, thanks, Chitwood. It's always a pleasure talking to you and good to see you. And that's all I had. I thought that was really good.
Yeah, appreciate it, man.
Yeah. Thanks, everybody, for listening.
Wild Turkey Science is part of the Natural Resources University podcast network and is made possible by Turkeys for Tomorrow, a grassroots organization dedicated to the wild turkey. To learn more about TFT, check out turkeysfortomorrow.org.